So welcome to the fourth lesson in this mini-series, which is taking you through an introduction to computing, but specifically programming in Python. Now, this particular lesson is one of my absolute favorites, and the topic that we're going to be looking at is the third programming construct, which is called iteration. So that on the top right-hand corner, you can see that exciting pattern on the screen. Now that's linked to some of the deepest mysteries of the universe, and it's called the Mandelbrot set, and we're going to be looking at that first. We're also going to be learning about loops, iteration. We're going to actually be building some visual graphical patterns using for loops in Turtle and Python, and then we're going to go on to while loops and make a mini program, a complete quizzing system with a login function which moves on to questions with a scoring feature as well. So lots to look forward to, and let's start with the Mandelbrot set. Now this strange visual behind me is in fact the Mandelbrot set, and it's something you can look up if you're interested in it. It's an extraordinarily simple concept, and it's actually defined by an equation of just two terms, so z squared plus c. Now, what's happening is that you feed a number into the computer, and obviously in the days of computers this couldn't be done without computers, and you repeat the process. There's hundreds of iterations, hundreds of loops, and you plot the result on the screen, and that's what we're looking at. Now, how it works is it divides all possible numbers into two classes, and it separates one class of numbers from the other. So you go into any area and you tell your computer to recompute that area, say that, and then blow it up on the screen. So what you're doing is you're using your computer like a microscope, and you're peering deeper and deeper into the layers of this mathematical mystery. Now, because of probability, this is interesting. If you do this yourself and you're looking into a particular part of it, it's probable that no human being has ever seen what you're seeing, the patterns that you're seeing. So this is an example of mathematical infinity. It can go on forever and ever, and it's limited only by the capability or the capacity of your computer. So I want you to remember three words that I said. I mentioned the word infinity, something that goes on forever. I mentioned iterations and repeating, and these words are very key for what we're about to learn. So before we really get into some coding, and we're going to do lots of it, let me remind you of the three programming constructs. It comes up in many exams, you need to know them, and they are sequence, selection, and iteration. And we've covered the first two. So we've worked with sequence, just means a sequence of instructions. Selection, we've worked with if statements, and we're now going to look into loops. So iteration is just a fancy word for loops. So what are loops and how do they work? Now you can go through the PowerPoint and read some of these things at your leisure, but in its simplest terms, a loop is something that simply repeats itself. So remember, when we were looking at the Mandelbrot set, we noticed that there was lots of things repeating. You kept seeing the same pattern again and again. And a loop is just something that repeats itself. And in programming, it's obviously a bit of code, or a line of code, or lots of code that repeats itself again and again. If you don't tell it to stop, it will go on forever. So a loop must have a stopping condition, or it'll just go on forever. And of course, a computer is not infinite. It has finite resources, and therefore if you create an infinite loop, it's a bit like creating a virus, and it would crash after a certain amount of iterations, depending on your computer's capacity. So what is a loop? You've got to remember that a loop is a control structure, just like if statements control the flow of a program. A loop is also a control structure, and it must have a stopping condition. There are three different types of loops that we come across in Python. We're going to look at the for loop first, and we're going to actually build some visuals, some exciting visuals, fractals in a minute. There's a while loop, which is invaluable, used all the time. We're going to make a quizzing system in which that's used. and of course a nested loop, which is just a loop within a loop. So let's get started with some actual coding. Now this is really amazing, and what I'm about to do is demonstrate to you how iteration, or repeating, which is loops, how it works by creating our own very beautiful pattern using mathematics and numbers. Now you can do this yourself at home by going into a program in your browser called trinket.io, and if you start by simply copying down what is on the screen. So don't worry too much about this beginning point, but we're essentially importing Turtle, which is going to be something which allows us to visualize graphics on the screen for the Python code that we're writing. And this is creating a pen that we can use. Now let me show you how this works. So once you've copied this exactly, we've got a color, you can choose your own color there. I'm going to write my pen dot forward 40 and then left 90, and you can see what happens is it draws a line on the screen. This is moving forward by 40, and this is about the angle. So if I change that, you'd see that the angle, if you look at the little triangle there, the angle changes. So how would I, from these two lines of code that I have, how would I make a square? Now have a look at what I'm doing. I'm going to copy that. So note that I'm repeating it, and it does that. So logically, if I copied and pasted it again, it produces the third side of the square. So see if you can pause the screen. Hopefully this is pretty easy. How would you complete the square? Of course, to complete the square, you do that. Now, we've created a square, and you can see, and this is the important thing that I want you to focus on, we've been repeating ourselves a lot. And remember, loops and iteration are pretty much about repeating a command. Now, one of the things that you could do to reduce the code that you're writing, to reduce the repeating and the duplication, which is important. Remember, if you have millions of lines of code, any reduction in code would be a huge benefit, and it's also just more elegant. You could recognize that you're repeating these two lines again and again. So let's count how many times. We have 1, 2, 3, 4. So I could write a command, and this is where a loop comes in, and we're going to use a for loop to repeat these two lines 4 times. So how do we do that? Have a look at this. So I'm going to write for I. Now I stands for an integer. You could write anything, you could write count in there, and it just means a starting number. So for I in range, we're going to give it a starting value of, say, 0 or 1, and we want it to go up. Remember, we said 4 times, so let's just experiment for a minute. I'm just going to write 4 and see what happens. Now remember, everything inside, we use a colon at the end there, and everything inside a loop, just like how it is in an if statement, would be indented inside that loop. So I've done something here. I'm going to press run, and let's see what it does. Well, it's doing something, so it's producing it once, twice, and then 3 times, but it's not going on to the next one. And the reason for that is here is the count. So this is the command for the count, or the number of iterations, the times that your code is repeating. And it's starting at 1, and it has 2, 3, and then it stops at 4. So if I change that to 5, you see that we have a square. So what I've done is I've produced a square without having to write loads and loads of code using a for loop. So this is where it gets really exciting. So we have a square, and imagine if we wanted to change the position to produce some sort of, beautiful, one of those fractal pattern type things we see. So we could do something like this, like just at the end of this, remember these 2 lines of code, and anything inside this loop is going to repeat 4 times. So if I added a change of position, such as, let's add maybe an offset of 10. Okay, so this is changing the position. Watch what happens. Sort of completely changes the pattern. If I did that, it draws the square, and then it draws a square next to it. And this, remember, this line is changing the code, so let me copy that whole thing again. That's interesting. So I'm beginning to form quite a beautiful pattern, as you can see, by copying and pasting this code again and again. So again, we're repeating ourselves. Let's do it once more. Oops, make sure it's to the left. Right, so we're getting somewhere. Now, obviously, you can see this is going to get really, really confusing if I keep repeating myself. So let's try and make it a bit more modular. So we have 2 things that we're repeating. We've got this for loop which makes a square. So why don't we put this into a function called create square. So I'm going to highlight that, indent that inside the function. So this whole function creates a square, and this little bit of code here changes position. So let's put that in a function as well. So change position. Now, if I create a square, so what I'm doing here is I'm calling this function, create a square, and if I then also change position, this is called changing position, isn't it? It produces a square for me and it changes the position. So if I create a square, it does the next one, change position, and notice I'm only having to call the function. I'm still repeating, so I'm still using lots of repetitions, but I'm writing less code. But as you can see, I'm still repeating, so there's still room for improving this further. You can see it's produced quite a beautiful pattern. Now, what if I wanted to go round this about 100 times? How would I go about doing that? You can see again that the 2 lines of code that I'm constantly repeating here. So I could just put these 2 in a for loop, like so. So I could say for I in range, maybe starting at 1 and say going up to 10, colon, highlight these and indent them, and have a look at what happens when I press run. So it does that 10 times, and I could be really ambitious. I don't want it to crash my computer, but I'll say 20, and you'll see that it repeats that 20 times to produce a really beautiful pattern. And there's unlimited different things that you can play around with to see how this works. But this very simple thing, demonstration using Turtle, really shows you the power of using loops in programming. Just as a final look at some patterns, you can see that changing just one tiny thing can entirely change your pattern. So for instance, I could add one more line in the create square function, and let's change that to 30. So it's going to be repeating, calling this function and this function 30 times, and let's just press run and see this beautiful pattern emerge. So why don't you have a play with this and see what you can produce? Really think about how loops work as you're doing it, and particularly in this case the for loop. So remember, the for loop has a starting value, in which in this case is 1. It has a stopping value, in this case is 30. It must, every loop must have a stopping condition, otherwise it would be infinite. So these are really key things to remember and to grasp about for loops, which are used, as I mentioned, in absolutely every possible program instance that you can think of. So what we're going to do now is we're going to, in the context of creating what's a little quizzing system with a login function as well, we're going to use while loops and everything else that we've used in previous lessons, including multiple functions, incrementation, passing parameters. So let's get started. So we're going to begin by making a login screen. And this time we're going to limit the tries of the user to, say, 3 or 100 or whatever you'd like. And that's going to lead in to a quizzing screen, which is going to allow a student or whoever it is, a quizzer, to take a quiz and be scored. So let's begin by just creating a login function. So I'm going to do that. Have a little heading. You have your username, just like you would in Google or any social media that you were logging into. Enter password. And of course you're going to have an if statement now which says if username is equal to, say, quizzer, and password is equal to open123. Then print access granted. Now, it's useful to note that we're doing this. This is not really how it's done in real life. So, for instance, on Test and Track or a site, if you were creating a website, you would be reading these usernames and passwords from a database file. And if they match, then the user would be access granted. But in this case, we're just going to do it like this for simplicity. Now, if access is granted, we would like them to jump to another function, which we'll create in a minute. Else, we would like them to say something like, sorry, try another time, something like that. Let's quickly make question 1, otherwise it's going to come up with an error. So let's call it question 1 and say something like question 1, so it's ready to go. Right, now I would like to start with this function, login. So I call the login function there. Let's see what we have so far. So I put in quizzer, open123, and it takes me to the quiz, but it's not limiting my attempts. So if I put in some nonsense there, it sort of just stops me. And I want it to give me 3 attempts to actually try and log in. So let's get onto that. So now what we're going to do is we're going to try and limit the number of tries that a user has to log in using their credentials by using a while loop. And in order to do this effectively, it's also useful to have what's called a boolean variable, which is also called a boolean flag. So let's start with that. Now, we're going to make a local variable, so we're going to do everything without using global variables, and I'm going to declare a variable called tries. I could call it anything I wanted, attempts, anything that makes sense to you and is meaningful. Call it tries, and of course the number of tries that a user has had to log in is 0 to begin with. I'm also going to have a boolean variable, and you'll see how this works. We're not going to use the full functionality of it, but it's useful for you to know. Now, you could call it anything. A boolean variable is a variable which is different from any other variable which can hold different values, in that it can only hold one of 2 values, and that is, it can either hold true or false. So if you consider the variable logged in, of course, at the moment, it's false because the user has not logged in. And while the user has not logged in, so listen to what I'm saying, while the user has not logged in, that variable is false. But if they have, it becomes true. So let's set up a little while loop. I'm going to say while the tries is less than 300, you could set it to whatever you wanted, 3, and logged in, this little variable, boolean variable, is equal to false, then I would like to do everything in this loop. So I highlight the loop, the contents of the loop, and I tab to make it indented. Remember, this belongs inside this while loop. So it's going to do something now. Let's have a look and see what it does. Now at the moment I'm not actually calling the login function, so let's do that. It says enter username. So if I put in some nonsense, it says sorry, try another time, and actually gives me another opportunity to try. So let me try again. This is attempt 2. Let me try again. It's not, well, interestingly, from what we did before, it is giving me the opportunity to try again, but it's not limiting my tries. Now see if you could pause the screen and think logically about why that's not happening. So if you've had some time to think about why it's not working, you may have realized that actually here is the stopping condition. So remember we talked about stopping conditions in any loop, which is necessary, otherwise they're just infinite, they go on forever, depending on your computer's capacity. So this is the stopping condition. It says when tries or while tries is less than 3. So if it goes above 3, stop doing the loop. And also then we would change this logged in variable to true. But at the moment, tries remains 0 throughout the program. Throughout this loop, tries doesn't really change, and it should change, because when the user gets it wrong, such as here, tries should go up to 1, and if it gets it wrong again, it should go up to 2. So what does that sound like? It sounds like incrementation. So over here, I could go tries plus 1, and really this could go in a different place, but for now, let's just change that to that for now. So I say quiz and I get the password wrong, attempt 2, oh no again, try again, and this time it actually ends the program. So you can see it's worked correctly, it's limited my tries as we've used this correct incrementation, and it is actually meeting this stopping condition here. So a useful fact to remember is whenever you use a while loop, the start and the stopping condition is not built in. You have to actually build it in. That's why I love for loops. It's all done for you. You have an initial starting condition or a value, and you have a stopping condition. And it does it automatically in a for loop. But in a while loop, you have to define the beginning, the starting condition, and you have to define the stopping condition, and you also have to make sure that somewhere in the program you are meeting that stopping condition. Otherwise you've created an infinite loop. Now over here, logged in is equal to false. Of course, if access is granted, we would also like logged in, that variable, to turn into true, and that would also exit or break out of the loop for us. So now that we've set this up, we can have some fun with it. And as I mentioned before, we've got this login function. Let's add a little comment there. We'd also like to add some quiz functionality, very basic, and with a scoring feature. So how we do that, as we can see at this point, it is jumping to this function called question1. Right, down here. So down here, let's start padding out this function with some, sure you can see what I'm writing there, yep, with some questions. So I'm going to start with a basic question. So remember, we have a variable into which the value will go, the input that the user puts in. So answer 1, you can call it A1 for simplicity, anything you choose. And let's say, what is the last book of the Bible? Now, if you know the last book of the Bible, it is Revelation. So if I said, if the answer, answer 1, make sure you get that correct, is Revelation. Now this is interesting. Let's use a little boolean operator here, because they might answer the question but use lowercase r. So let's say, again, answer 1, give them the option of not using uppercase. Then they get the answer right. So it says, well done, but it also gives them a score. A score goes up. So we don't have a score at the moment. So at this point down here, let's create a score variable, give it a score of 0, and print. score so far, score. And down here, what do? Incrementation, score plus 1. Just check that that is working. You can call it updated score. Sorry, I'm going to move that up so you can see it. Updated score is score. So what this should do, if I go back and I run the program, oops, it has an error there. So it's telling me that there's something wrong on line 23. So let's have a look. Can you spot something? Yep, there should be a double equal sign there. So that's done. Let's go back up again and run the program. Brilliant. So Quizzer, open 1, 2, 3, Revelation, and you can see that the updated score is now 1. So that's working. Now, a quiz doesn't usually have one question in it, usually has more questions, and there are many better ways to do this. You could use lists, you could use files to draw the questions and the answers. So remember, we're really doing this in a simple way to get you thinking about how programs work together. So for simplicity, let's do it in this way, but keeping in mind this is not the best structure. So after question 1, of course, if they get it right, the score goes up, and we would like it to jump to question 2. So that's the next bit that we're going to pad out. So you're now really starting to see how everything fits together, how you can build a complete program with all these interesting features. And let's add some stuff to question 2 over here. We have to actually make the function. So we go question 2, oops, let's do something like that. And we're going to have, of course, a question. We can have a separate variable called answer2. What could the question be? It could be something like 3 programming constructs are, spell that right, sequence, selection, and question mark. Sorry, this is not perfectly formatted. So if answer 2 is, you should know that the third programming construct is iteration. Of course, we want to give them the option of being able to write iteration. Then the score goes up by 1. I'll come back to that one in a second. It says well done, or whatever it is, and it prints the score. Let's just say, keep it simple and just say print score so far is score. Now, this is not going to be recognized. And the reason for that is because score doesn't exist in this function. So if you pause the screen, think back to previous lessons, you should remember that the answer is passing parameters. So over here, when we call question 2, which is function question 2, we pass it the score, we receive the score, and now it will remember the score that was created in this function and pass it on to question 2. Right? So at this point we have 2 questions. We could have a final score. Let me go up now and run the program. So Quizzer, open 1, 2, 3, Revelation, you can see my score is 1, iteration, my score is now 2. So you've created a number of different functions. You've used passing parameters, iteration, if statements, of course, which is selection. So you've used all 3 programming constructs here. You've used sequence, selection, which is if statements, and iteration, which is the while loop. The while loop, along with a boolean variable, and remember a boolean variable can either be true or false and is extremely useful in all kinds of ways. See if you can expand and extend this program, improve it, and as you learn more about things like file handling and lists, your knowledge of how to structure a program and how to make things more efficient will only improve. Now behind me is somebody, not me, because I don't play this, playing Fortnite. And I'm not a huge fan of computer games. I think they can be a massive waste of time, but they can, they're fair enough for entertainment. And I did used to play Wolfenstein. In fact, that was the first ever Wolfenstein that came out, the first version that my dad brought back on one of these little Windows 3.1 machines. So that says something about how old I am. But anyway, now some of you are probably thinking, how are all the things that we've learned, things like sequence, selection if statements, and iteration, how does that apply to game design? So we looked at how it might work in a quizzing system or a website. What about game design? I think quite easily, if you pause the screen, discuss it, think about it, you'll see how an if statement might be implemented in a game design if they hit a wall, turn left, or that sort of thing. But equally, loops. Looping is a very, very huge part of game design in all kinds of ways, some of which we would need to explore further, looking at different constructs and different features that we can use in Python. But it is useful for you to think about game design, particularly for those of you who are interested in making games. And in game design, each frame in the game displays is one time through a loop. So it usually has like a game loop. And you've probably heard the term frames per second, FPS. So the frames per second, it represents the number of times that the computer updates the screen each second. And the higher the rate, the smoother the game. And again, this is all done using a loop or iteration. So something to think about, and the applications of iteration in game design. Now just to end, just a reminder that you can download the PowerPoint, which gives you all the information. You can go through it at your own pace, and it also has lots more information for those of you who want to get ahead and do more. And there's always some of you who want to do that, and that's really the key to getting good. The Fibonacci sequence that some of you studied in maths, this is a really challenging task where you might think about how to use a loop and iteration to recreate the Fibonacci sequence. So the PowerPoint has some tips and pointers on how you could do that. There's a task which uses, if you pause the screen, you'll see that that uses a while loop, and it's called a guess the number. This could be developed into like a bingo type app. This is the same thing that we did, so that was the challenge where you actually fix the login screen to allow it to have 3 attempts. And there's a number of other things, including just doing some analysis of code and looking at how it works. I must remind you of the official Python site and the documentation. If you want to be learning more, you need to be referring to it. Every time you have a problem, just Google and see that you check to see that you've used the right syntax and that you're doing things in the correct way. And actually you can extend your knowledge very deeply by checking out this Python documentation. So that's all for now. I would suggest that you did the corresponding test on iteration on testandtrack.io, and obviously do as much to extend your programs that you've done in this lesson, particularly playing around with Turtle, which is wonderful fun, to make sure that you've really understood everything that we've learned so far, which are the 3 programming constructs. Now just because it's so beautiful, let's end with one more pattern. So I'm just going to experiment with writing something else. So let's write left 40 there, and let's change that to 60 and run.